Hi, once again with a new video. I'm Viraj and this is my YouTube channel Maths by Viraj. I have uploaded videos for grade 9 and this is for grade 10 students who are doing the national curriculum. Because of the prevailing circumstances, we are unable to go to school. So stay home, stay safe and study so that you can get through your exams easily. Today's lesson, triangles. Right. To have a short idea and briefing of alternate and corresponding angles, I've drawn two figures. Here you see that two lines are parallel and this parallel line is been cut by a transverse line. Therefore, we know that this particular angle is equal to this angle. And the reason behind it is alternate angles. What is it? Alternate angles. These alternate angles are also known as Z-shaped or N-shaped angles. The other theory is this particular angle is equal to this angle. You see that again two parallel lines are being cut by a transverse line. So transverse line is a line which is drawn across two parallel lines, and therefore this is known as corresponding angles. These are also known as F-shaped angles, right? So the first theory that we are going to learn is exterior angle is equal to addition of the two interior opposite angles. That is, we have to prove that this particular angle is equal to addition of these two angles. On the other hand, I can write that angle ACD is equal to angle ABC plus angle BAC. So this is what we have to prove. Right, children? In order for me to prove that angle ACD, the exterior angle is equal to the addition of ABC, the angle ABC and BAC, that is interior opposite angles. So I am going to prove it. Right. I am going to draw another line or add another line to this diagram, and I'll mark this as line EC. I draw the line CE such a way that this line is parallel to line AB. So when proving, we can add lines as long as they are mathematically correct. Now we see that there is a triangle and there are two parallel lines which are drawn from the base BD. Fine. I can come to a conclusion, or I can say that this angle BAC is equal to angle ACE. Angle BAC is equal to angle ACE. Children, please understand that these two are two parallel lines. Therefore, these two angles are equal. Therefore, it is Z-shaped or N-shaped angles. Therefore, I can write alternate angles. Then I can write angle ABC is equal to angle ECD. Angle ABC is equal to angle ECD. Why? See, they are F-shaped. See, F-shaped. Therefore, these two angles are equal. We can call it as corresponding angles. Now, children, you should understand that angle ACE and angle ECD, they all add up to form angle ACD. Therefore, I can write angle BAC plus ABC is equal to angle ACE plus ECD. Collectively, I can write this write the addition of these two angles to be angle ACD. Therefore, angle ABC plus BAC is equal to angle ACD. Exterior angle is equal to the addition of the two interior opposite angles. Very easy. Children, my intention is to do a lot of proving sums with you all. The reason is I know that children find it difficult to prove. Yes, you might not get a lot of proving in grade 10, but in grade 11 you will get a lot of proving. Therefore, let's try to do this sum. Now we have to prove that angle QPR is equal to angle PSR. Therefore, QPR, this whole angle, is equal to PSR, this angle. Very easy. Now, if I am to break this diagram into two equal diagrams are equal but the angles are different. Children, this is the way that you should think and do the sum. Now children, here this is what needs to be proved and this diagram shows what is given in the sum. Right. Now if I consider angle PSR, this particular angle. Right children, let's redraw this again. P, S, R and Q. This is the angle. This is what is given to us and I will mark this another angle. Now you can see that PSR, angle PSR is equal to addition of the two interior opposite angles, because angle PSR is the exterior angle to the two interior angles QPS and PQS. PQS plus QPS. Fine. Children, they have already given to us the fact that angle PQS is equal to angle SPR. These two angles are equal. Therefore, instead of this particular angle, what can I write? I can write SPR. Angle SPR. Therefore, I can write PSR angle is equal to angle SPR plus QPS plus QPS. These two angles, yes, these two angles are equal to this angle, but instead of this particular angle, I am naming it as angle PQS, because they have already given us that these two angles are equal in value. Right. Actually, we have proved the theorem which needs to be proved, but let's try to understand this. This particular angle is angle SPR. This is the angle SPR and this is the angle QPS. Therefore, you see that these are the two adjacent angles for the angle QPR. Therefore, I can write all of this as angle QPR and this is equal to PSR. So we have proved what needs to be proved. Right children, let's look at another sum. Here the diagram is given and we have to prove that angle BAC plus angle ABC is equal to angle DEC. That is, these two angles is equal to this particular angle. So that's what we have to prove. Children, I am going to redraw this again. Again, angle BAC, this particular angle, plus angle ABC. So we have to prove that the addition of these two angles are equal to angle DEC, right? Now let's consider the whole diagram and think about the two parallel lines DE and BC. We can say that this angle is equal to this particular angle. Very easy. We can say that angle ABC is equal to angle ADE. Why? Corresponding angles. Therefore, now if I redraw this diagram in such a way that ADE, right? Children, I may mark this as C. I can say that angle DAE plus, that is this particular angle, plus ADE. ADE is equal to DEC. Yes. Why? Exterior angle is equal to addition of the two interior opposite angles. Fine. Now DAE angle is also the same angle as BAC. Therefore, I can write this as BAC. And instead of ADE, I can write ABC. Why? These two are equal because of the theory corresponding angles. So instead of ADE, I can write it as ABC, which is equal to DEC. So this is what needs to be proved, and we have proved it. So the basic theory that we have used is here the exterior angle is equal to the addition of the two interior opposite angles. The total value of interior angles of a triangle add up to 180. Right. This is the proof of it. Now children, let's look at this. This is a normal simple triangle. Now what I am going to do is I am going to extend the line BC further up to D. Then I am going to draw another line from C and mark it as E. I draw the line CE in such a way that line CE is parallel to line AB. Right, children? Now, looking at this diagram, we can come to certain conclusions. That is, angle ABC is equal to angle ECD. Yes. What is the reason? Corresponding angles. Angle ABC is equal to angle ECD. Let's mark this as equation number 1. And the reason is corresponding angles. Right. The next comparison that I can come to is angle BAC is equal to angle ACE. Again, angle BAC is equal to angle ACE. Let's mark this as equation number 2. And in this case, now it's not corresponding angles but alternate angles. Right. Children, if I draw the straight line BCD, it would look like this. I can say angle ACB plus angle ACE plus angle ECD is equal to 180 degrees. Why? Angles on a straight line add up to 180 degrees. Therefore, ACB plus ACE plus ECD is equal to 180. Fine. Now, using equation number 1, instead of ECD, what can I write? ABC. Instead of ACE, use equation number 2, I can write it is equal to BAC. Now, the angle ACB, you can see that this is common for the triangle ABC as well as the straight line. So we can write it as ACB. Now you see that these are the angles which are inside the triangle. So they add up to 180. So what I have done is I have converted converted all the angles to other angles, some other angles. That is, I have found the relationship between angle BAC and ACE, alternate angles. Angle ACB is common. You see that this angle is common. This angle is equal to this angle. That is this. And angle ABC, I have proved that it is equal to angle ECD using corresponding angles. Therefore, angles on the straight line add up to 180. Likewise, using the comparisons and the equal angles, I can prove that angles in the triangle ABC add up to 180. Okay children, let's look at another sum. Here, we have to prove that angle ABD is equal to angle BCD. That is, we should prove that these two angles are equal, right? So we should look at the data that is given to us. So it is given that angle ABC is a right angle 90 degrees and angle BDA is a right angle. So children, if BDA is a right angle, ADC being a straight line, then we can come to an understanding that angle BDC is also a right angle. So whatever the data that we understood, I have drawn it in two diagrams. So what are the things that we have understood now? Right. These are what we have understood. We can say we know that angles in a triangle add up to 180. Therefore, I can say angle DBC plus angle BCD plus angle BDC is 180. Angles in a triangle add up to 180. But we know that angle BDC is 90 degrees. Therefore, DBC plus BCD plus 90 is 180. DBC plus BCD is 180 minus 90. Therefore, angle DBC plus BCD is equal to 90 degrees. Let this be my equation number 1. If we consider triangle ABC, we can see that angle ABD plus angle DBC is equal to 90 degrees. Angle ABD plus angle DBC is equal to 90. Let this be my equation number 2. Right. Now you see that these two angles are equal to 90. So if I equate 1 and 2, equation numbers 1 and 2, it would look like angle DBC is equal to angle DBC plus angle BCD is equal to angle ABD plus DBC. Right. Now since these two are on both sides, we can cancel off them. And see, we have proved now angle ABD is equal to angle BCD. Very easy proving. Children, for the following question, it says, in the quadrilateral PQRS, the sides PS and QR are parallel to each other. The bisectors of the interior angles P and Q meet at O. Prove that angle POQ is a right angle or angle POQ is 90 degrees. Right children, based on the data that is given, we know that these are angle bisectors, which means that this particular angle is divided into two equal angles. Likewise, these two angles are equal in value. Now children, what can we say about angle SPQ and angle PQR? Children, these are two parallel lines and these two are the right angles and they add up to 180. They add up to 180. Right, right angles, or we can say interior angles, C-shaped or U-shaped angles add up to 180. Now children, if I consider the triangle PQO, if I consider the triangle PQO, I can say that angle PQO is half the angle PQR. Angle PQO is half the angle PQR. Similarly, I can say angle QPO is half the angle SPQ. QPO is half the angle SPQ. Right. So, half and half. What can I say? If these two angles which are in full add up to 180, half, if I multiply everything by half, what is going to happen, children? I have to multiply this side also by half, which gives me half SPQ plus half PQR is half times 180 is 90. Now, what is half SPQ? QPO. What is half PQR? PQO, which is equal to 90 degrees. Fine. So, if I consider triangle OPQ. Now, QPO plus PQO plus POQ is equal to 180. Why? Angles in a triangle add up to 180. Now, these two collectively have got a value of 90 degrees. 90 plus POQ is 180. Therefore, POQ is 90 degrees. So, we have proved what needs to be proved. Children, we have finished one whole lesson today. So, subscribe Maths by Viraj for furthermore videos and click on the bell icon so that you will be notified as soon as I upload a new video. So, stay home, stay safe and see you in another video.